Section 6.6 is about trapezoids and kites, so the last type of quadrilaterals. A trapezoid is a quadrilateral that has exactly one pair of parallel sides. So here's an example of a trapezoid. Just some vocabulary. Your bases are always the sides that are parallel. Your legs are the non-parallel sides. And then your base angles are the two angles that share the base of a trapezoid. So these typically are called your base angles, and then all of those. An isosceles trapezoid, remember isosceles means you have two sides that are the same. So an isosceles trapezoid means that the legs are congruent to each other. So I just put in here to give you that picture so that you know what to look for. So let's look at some theorems. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So if I have an isosceles triangle, these two pieces right here, then I know that my base angles and these are going to be congruent to each other. Another theorem about isosceles triangles is 620, which says if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So if I have an isosceles triangle, then I know that this entire length of the diagonal is congruent to this entire length. Now let's put those theorems to use. So the first piece, find the measures of the number of angles in each isosceles triangle. So notice here is my isosceles trapezoid. First thing I see is since it's isosceles trapezoid, these base angles are going to be congruent to each other. So I know that angle 1 is the same measure as this angle. So since it's 109, I know that angle 1 would be 109. To find what angle 2 and 3 are, I have to do some math. So remember, a trapezoid is a four-sided figure, so all of those angles will add up to 360. So what I could do is I could take 360 minus 109 twice, and that would give me what's left over, which is 142. And then I could divide it by 2 since these two are congruent to find what one of them would be. So you have to do some math in order to figure out what the 2 and 3 would be. Now pause the video and see if you can do question 3. So question 3 is a similar setup to the last one that we did. So angle 3 is going to be the same as this angle over here. So angle 3 is going to be 44 degrees. Then you have to do some math to find what the other two are. So you would have to take 360 minus 44 twice, and then that difference you would have to divide by 2 to find what angle 1 and angle 2 would be. So you should be getting 136 for both of those and 44 for the third. Okay, so now let's look at some problems where you don't have just the numbers, you have expressions. So now notice that they're giving me 48 in the base angle, and they're also giving me an expression 5n plus 3. Well, we just got done discussing that these base angles are congruent to each other. So if they're congruent, I'm going to set them equal to each other so I can solve for n. So I set them equal, I minus 3 and got 45, and then I divide by 5 and got 9. Pause the video and see if you can do number 9. Okay, so on number 9, I see that we have, again, an isosceles trapezoid, but this time they're giving me the diagonals. So this theorem we haven't used quite yet, but it's theorem 620. So if I give the diagonals, I'm just going to set them equal to each other and solve. So minus 1x from over here and add 2 over there would give you x equaling 7. Okay, so the next page of your notes deals with some kites at the very top. So before we get started, let's talk about what a kite is. So a kite has two sets of congruent sides. So these two sets up here would be congruent, and then these two sets down here are congruent. The other piece which you need to note on your note-taking guide, because it's not wrote down, is that it will have one pair of opposite angles that are congruent. That will always be the set that's in between your two different side lengths. So these two, B and D, are congruent, not A and C. Okay, so you want to look for where you have your tick marks, where you distinguish between the 1 and the 2, that's going to be my angle, and then opposite that angle. So we're going to use some of that properties of what a Oh, let's do that Theorem 622, I'm sorry. So on Theorem 622 it says if a quadrilateral is a kite, then its diagonals are perpendicular. So first off, we know if it's a kite, these sides are congruent. We know that those opposite angles are congruent, just that set, not both, just that set. And then if I have diagonals, it will always intersect at 90 degrees. So let's apply some of that up here for these kites. So I'm working your way back up here. So on question 15, they gave me this angle is 98, this angle is 110, and then I have to find 1 and 2. Okay, remember we said one pair of opposite angles is congruent. That pair is in between where you have 1 tick mark and 2 tick marks. So I know that this angle and the opposite one, which is over here, are congruent. So I would say angle 1 is 110 degrees. Then you're going to have to do some math to figure out what angle 2 is. We have a four-sided figure, so all of my angles have to add up to 360. So you're going to take 360 and just subtract away 98, 110 2 times. And when you do that, you end up getting 42. Okay? All right, let's try the next one. 16. They want me to find angle 1, angle 2, angle 3, and they gave me this angle is 48. It's showing me that this is a kite because these two sets and those two sets. So the first thing I see is that I have diagonals intersecting. So from Theorem 622, I know this angle will be 90. So if I did 180 minus 90, this angle would also be 90. So angle 2 has to be equal to 90 degrees. Now, angle 1. This is applying some of your triangle, third angle sum theorem. So remember, if I have 2 of my 3 angles, I can add them up and then subtract them from 180. So I took 180 minus 48 minus 90, and that's how I got angle 1. So that would be 42. Another piece from previous knowledge, notice that these are right angles right here, so I have right triangles. If I have a right triangle, they are congruent to each other by the hypotenuse leg theorem. I have a hypotenuse congruent and I have a leg congruent. So angle 3 would be 48 degrees, the same amount as this, because these two triangles are congruent to each other. So what you're going to find in some of these problems is you're going to be seeing that triangles are congruent, and so you're going to see that some of these angles are congruent based off of that. Okay, see if you can try 17 on your own, so pause the video. Alright, on question 17, I see that we have a kite because we have the two sets of congruent tick marks. So notice that I only have one diagonal, so I can't do anything with the 90 degrees. However, I do know that if I have these triangles, so if I look at it in terms of this being a triangle, this is an isosceles triangle, which means that these base angles have to be the same, and the same can be said over here. I have an isosceles triangle, so these base angles are the same. So that means that angle 1 and angle 2 would be from base angles, so angle 1 is 70 and angle 2 is 54 because they're isosceles. Okay, angle 3 now. So then to find angle 3 and angle 4, you're just going to do that third angle sum theorem. So take 180 and minus 54 2 times, and you would get 72 for angle 3. You would do the same thing for angle 4. Take 180, subtract 72 times, and you would get 40 for angle 4. So again, notice that you're applying some of your triangle stuff in order to solve these. Okay, so that's talking about a kite here, so let's apply a little bit more and just drop down here. Alright, so on question 19, it's giving me these expressions and it's asking me to find what x would equal. So the first thing I see is they're giving me this angle, and they're giving me this angle, and then they give me one clear over there. Well, not very successful in helping me unless you know that something about those could be useful. So one way that I did it was, I know that my diagonals are going to intersect at 90 degrees, and so I now have all 3 angles for a triangle. So what I did is I set up an equation and added 4x plus 90 plus 2x to equal the 180 for this triangle. There are other possibilities that you could do in order to solve this, but that's one way that I did it. So then I combined my like terms and got 6x plus 96, subtracted 96 from 180, and then divided by 6, so x is 14. See if you can do number 20. Alright, so on number 20, I noticed that these triangles were congruent because they had one side, a second side, and then here is your third side that's congruent, so they're congruent by side, side, side. So based off of that, I know that this angle is congruent to that angle because of corresponding positions. So I set 3x minus 5 equaling 2x plus 10, and I solved it by subtracting 2x and adding 5, so x is 15. Then what I did was I plugged 15 into this expression and got 40, and I added 40 plus, and since I have congruent triangles, I know that this angle is also 27y, so I added all three angles to equal 180. So I did 40 plus 27y plus 6y plus 8 to equal 180. And then I solved it. So I combined my like terms and got 48, 33y, subtracted 48 and got 132, and then divided by 33 to get y equals 4. Now these are pretty in-depth problems because you're involving prior knowledge and then you're also applying new material. So it is somewhat difficult, so just take your time and try and work through those, otherwise let me know if you have questions. The last piece that I put on there was just a summary of all of the quadrilaterals that we did. So at the top it's just starting with a quadrilateral, and then based off how many parallel sides will depend on where it starts. So a kite has no parallel sides, so it's by itself. A trapezoid has one, and then if it has two pairs of parallel sides, then it's a parallelogram, which pushes you off into those. So if I'm a parallelogram, then I could be a rectangle, a rhombus, and then both of those branch into a square. So just trying to show you what pieces we have done. Okay, that is it for trapezoids and kites. So if you still have questions, let me know.